Hello, I'm Richard Patterson. I'd like to welcome you to another IPC Irwin video where we're featuring the semiconductor laser. Now we'll have a walkthrough of this piece of apparatus, but just to let you know what you can use it for, as well as for senior high school experiments looking at young slits and the diffraction grating, we can also use it in junior high school for geometrical optics. And if you're teaching communications, we can also use the laser to modulate the beam and receive it remotely using some of the apparatus in front of me here. So just walking you through the controls on the machine, very straightforward. There's a warning, a health and safety warning. It's a class 2 laser product, so it's not advisable to shine the laser beam into your eyes, and make sure it doesn't reflect off any surfaces into anyone's eyes when you're using it. It's got a cover on the top there, and which should always be put back when not in use. And if we rotate the casing, you can see some of the parts. So if we look at the rear panel, we have a key switch. We can use an external power supply, but there is a 9-volt battery inside, accessible by this compartment here, just hidden on the bottom of the casing. And these jack sockets allow us to connect up a modulated signal from a radio when we want to use this to demonstrate communications over using a laser beam red's light. So I'll just switch it on using the key switch, and if I remove the lens cap there, the laser beam is producing a dot on my hand there. Now if I want to change the diameter of the beam, there's a little focus control here, and I can adjust that to produce a much broader beam. So we've set the laser up here to try and measure the wavelength of the light, the red monochromatic light from the laser, and it should be possible to get within 1% of its value. We position the laser around 2 meters away from the screen and place in between the diffraction grating, which has got 100 lines per millimeter. Looking at the diffraction pattern, I'll take the diffraction grating away, and there we just see the reflection of the laser beam on the white screen. And if we just slide it back, we can now see the diffraction pattern with a central bright dot, and either side 4 dots showing the first, second, third and fourth diffraction patterns produced by the screen. So I'll now take some measurements with simple meter rules, and we'll show you the calculation in a later graphic. So I'm going to first measure the distance using a tape measure, centimeter tape measure, from the central dot to the screen there, and that's coming in at about 127 centimeters. We then just need to measure the distance between the diffraction patterns, and it's coming out at 8 centimeters as I go out for the first, second, third and fourth fringes, and it's the same on the other side. So I'll record those 2 measurements in my data table, and in this graphic that follows, I'll show you how we can work out the wavelength of the light. So thank you for watching this video about the semiconductor laser. Here's our QR code, and as usual you can access using this the IPC Irwin website, where you'll find our setup instructions and safety instructions. Particularly important when using this that you've followed the CLEEPS laser instructions, so we put that code in there as well. And there's a host of other experiments that are featured on the Institute of Physics Spark Practical Physics website.